So now, again, not now, because this was already figured out earlier, but I'm going to show you the engineering that resulted. So we redesigned the stator, right? So at this point, the stator coil design had to go to a coil manufacturer. It's not common to have coils at 13,200 volts or 13,800 volts, or there's fewer of those motors out there, and there are few manufacturers that do a good job. We happen to work with this company that's in England, and they manufacture the coils. So they gave me a CAD drawing, we approved that, and we prepped the stator. What you're seeing there is the stator without the windings. And then we started winding it. So the coils were made, coils were inserted. I'm briefing through this quickly, but we're tying it in, blocking and bracing, doing all the things you need to do to keep it secure, tying it in as you go, and then lifting the final span to where you have to insert the lap coil. The reason that's lifted is you can see the geometry of the coil right here. When I get here, I got to get underneath those coils, so they have to lift the span. And that's not as easy said as done, because these are really special coils. The coils actually had to be heated up with a DC welder, pass current through it, to heat the coils up so that they became more flexible. If I didn't do that, it would crack the coils. So just another process that you have to look at. So all completely coiled and then electrically tested. Then we were doing our brazing for our series connections. We call them UEs. Putting it all together, and then finally connecting the leads and having the leads come down like the original motor at the 6 o'clock position. And then the finish after it was baked in an oven, and then we actually applied an additional epoxy resin on the outside.